Hello, and thank you for joining us on our lecture about circuits. In this circuit lab, we're going to show you how to measure voltage and current.
For this introductory circuit lab, we will utilize four components. A breadboard, which is used to easily prototype circuits so that you don't have to solder pieces together, as you can see by the nice grid of holes that it has on it. A 1 kilo ohm resistor, a digital multimeter, which we'll use to measure voltage, current, and resistance, and a DC power supply, which is the bottom unit. We will use this to supply a steady voltage for our lab. To begin, let's measure the resistance of our resistor. So we'll take our 1 kilo ohm resistor and we'll connect it to our multimeter. We'll set the multimeter to the resistance measurement, and we will connect both leads to the resistor. We now see that this resistor is supposed to be right around 1 kilo ohm, or 1,000 ohms. We go and check our reading, and we see 0.982 kilo ohms, or 982 ohms. This is well within our 5% specifications.
As you can see, when we are measuring voltage, we measure it in parallel, meaning one terminal is placed on the first side of the resistor and the second terminal is placed on the other side of the resistor. Now, we'd like to measure current. We'll first start by changing the setting on our multimeter to current. And as you can see, it is reading current in milliamps AC, so we need to change it to DC. Now, to measure current, you need to first change this terminal on your multimeter and then wire your multimeter in series with your circuit. So we will do that by first removing this terminal of the resistor and taking this terminal from the back side and hooking it to a jumper wire. We will then place this jumper wire in the same terminal as the power supply. Now we can see that the multimeter is reading negative 10 milliamps. And the negative 10 has to do with the polarization of the leads. So if we were to switch these to the other way around and take another look at our multimeter, you would see that it's now reading 10.2 milliamps, which is what we would expect for a 1 k ohm resistor.
Now, we have two 1 kilo ohm resistors, and we will cover resistance in series and parallel.
Let's start by taking the leads to our power source and placing them in the breadboard. Now we're going to take our 1 kilo ohm resistors and place them in series. This is done by overlapping one of the terminals in the same line in the breadboard and connecting it to the other terminal of the power supply. Now these resistors are in series, and as covered in our previous videos, our resistance should be roughly 2 kilo ohms. Now to verify, let's measure the resistance with our multimeter. So we'll take one lead and connect it to one end of the first resistor and the opposite end of the second resistor. Now if you take a look at our multimeter, you can see that the resistance value is 1.96 kilo ohms, which is about what we expect.
Before, when we had this wire plugged in nearby, we experienced a little bit of a parallel circuit, where you can see our resistance is a meaningless value, mainly because we're creating a circuit that we don't know what resistance it is with the power supply. So when we take this back out, our resistance goes back to 1.96 kilo ohms.
Now let's measure the voltage drop across the two resistors in series. We first do this by changing the setting on the multimeter to DC voltage. Then we will turn the power supply back on to 10 volts. And as we expect, the 10 volts will be dropped across the two resistors. And you can see that this is the case. Since both of these resistors are 1 kilo ohm, we would expect that approximately 5 volts is dropped across each. So if we take the second terminal that was connected to the second resistor and place it on the second terminal of the first resistor, we will see that approximately 5 volts is dropped across the first resistor, which then means that 5 volts will be dropped across the second resistor. But for good measure, we will check. And as you can see, approximately 5 volts is dropped across the second resistor. Now we'll take our series circuit and connect it in parallel. We'll do this by disconnecting the common node of the series resistors and taking them so they each span across the terminals of the power supply. This is done as so. Now we will turn on our 10-volt power supply and assure that we are still on DC voltage for our multimeter. We will then connect the terminals to the terminals of one of the resistors in parallel, because as described in a previous lecture, resistors in parallel will drop the same voltage.
And, as expected, we can see that we are dropping 10 volts across these two resistors.
And for good measure, we can measure it across the other resistor by switching the terminals to the multimeter. And as you can see, it is still 10 volts. And now we can check the resistance of this circuit.
First, we will disconnect our power supply
And switch the setting on the multimeter to resistance. And as you can see, two 1 kilo ohm resistors is approximately 500 ohms, which is supported by what we've learned in our previous lectures. It is important to note one other type of circuit configuration, that is a short circuit. A short circuit is made when a connection is made between the source and the load, and will result in very high current values, which can be dangerous. Thank you for joining us on our last lecture on Circuit Lab.
We hope that you have enjoyed the entire series of videos and that it has sparked an interest and a desire to pursue either computer or electrical engineering.